Okay, the domain can x cannot be anything that's going to make the denominator 0. So if 5x cannot be equal to 0, then x cannot be equal to 0. So we'll write this as all the values of x such that x cannot be equal to 0. Number 2, there's no variable in the denominator, so this denominator can never be 0. So there's no restriction on what x can be, so that means that x can be anything from negative infinity to infinity. This is all real numbers. You could write this out like 4x plus 7 cannot be equal to 0, so that means that 4x cannot be equal to negative 7. So x cannot be equal to negative 7 over 4. So it's all the values of x such that x cannot be equal to negative 7 over 4. All of this work is unnecessary. It's always the opposite of this and this over this. So negative 7 over 4. So x cannot be equal to negative 3 over 2. So we have all the values of x such that x cannot be equal to negative 3 over 2. Okay, right off the bat, I'll cancel those, and I'll cancel 2 of these with 2 of these, making that an x to the 3, and then 7 goes into this twice and into this 3 times. So up in the numerator, we have 3x to the 3rd power, and in the bottom, we just have a 2. Here we're going to cancel that, and I can also cancel 4 goes into 8 twice, and then I'll cancel this x with one of these, making that an x to the 1. And remember, you don't ever write an x to the 1. Because the denominator is canceled out, we just write only the numerator. So the answer is 2x times 5x minus 3. These are opposites, backward, around, and negative, and you can cancel those as long as you pop a negative on the entire fraction. So our final answer is negative 8x plus 1 over 4x plus 1. You have to get rid of those parentheses because this fraction bar implies parentheses around the top and parentheses around the bottom, so leaving them there would be redundant. Again, I can cancel these as long as I pop on a negative, so I do that. And then I'm going to cancel the 3x plus 2, and then I'm going to cancel 3 of these x cubes, cancel with 3 of those. 7 minus 3 is a 4. And finally, 8 goes into 16 twice, into 24 3 times. So what we end up with is a negative 3x to the 4 in the numerator and a 2 in the denominator. Here I'm going to factor the top, and the top is going to be x plus 8, x plus 2. I'll factor the bottom, and this will be x minus 5, x plus 2, and then I'll cancel the x plus 2's, and we'll be left with x plus 8 over x minus 5. Okay, we got to factor the top and bottom. Factor it any way you feel comfortable with. But whatever, if you factor by grouping or slide, divide, slide, at the end of the day, we're going to have 3x and x, let's see, plus 4 plus 1. That works because 3x squared, the outer is 12x, the inner is 1x, and 12x and 1x add up to that, and this gives us a 4. On the bottom, we have a 3x and an x. Let's see, I have a negative 2 and a positive 1. That first is 3x squared, the outer is negative 6x, the inner is positive 1x, that adds up to negative 5, and the last multiplies to negative 2. But now that cancels, and we're left with x plus 4 over x minus 2. Because this is a multiplication, anything on top can cancel with anything on the bottom. So when I start canceling, this and this cancel. 4x plus 3 cancels. 5x minus 1 cancels. And we're left with 5x plus 1 over 3x plus 2. Okay, within each fraction, this is a division, so this is going to end up being flipped upside down. But within each fraction, I'm going to cancel this with this, and I'm going to cancel this with this. And then actually, because of this division, you can cancel across the tops or across the bottoms across this. So, well, if you didn't know that, you would just write down 5x minus 7 over 4x plus 3. Change this to a multiplication by flipping this upside down. And then you'll have 4x plus 3 over 5x plus 7. And then this cancels with this, and this cancels with this. So you end up with a 1. Now, if you had realized that up here, you could have canceled this with, oh, that's a 5x minus 7. Well, I take it back. Let me undo this. That can't cancel. Plus 7. So this and this can cancel. And so we're left with is 5x minus 7 over 5x plus 7. Now, what I guess I can't cancel this and this, but this and this could have canceled. And you can cancel on the same side of this because of this division. So if you didn't write it like this, you would have just gone here and canceled this and this. And then you would flip this upside down and be left with 5x minus 7 over 5x plus 7. So either way you want to do it. I have to factor each and every one of these. So when I factor this, this is x plus 5 times x plus 2. When I factor this, we have x minus 7 times x plus 2 times, when I factor this, we have x minus 7 times x plus 3. And when I factor this, I have x minus 5 times x plus 3. Because this is a multiplication, anything on top can be canceled with anything on the bottom. So I can cancel, let's see, x plus 2 cancels like that. I can cancel x minus 7 like that. I can cancel x plus 3 like that. And I'm left with x plus 5 over x minus 5. Okay, I'm going to factor everything. When I factor this, we have x, let's see, minus 6 and x minus 3. When I factor this, we have x minus 6 and x plus 5. I'll change this to a multiplication, and I'll flip this upside down. So now I'm going to factor this and put it on top. And this is plus 5 minus 4. And when I factor this, this is minus 3 plus 1. Okay, now, because this is now a multiplication, anything on top can cancel with anything on the bottom. So I'll cancel this. The x minus 3's cancel. And the x plus 5's cancel. And we're left with x minus 4 over x plus 1. For the LCDs, the number is going to be 10 because 10 is the smallest number that they can all go, both of those can go into. And then when we look at the x's, we have 2 here and 1 here. 2 is more, so that's going to be part of the LCD. And then we look at the x minus 4. We have 3 here and 1 here. 3 is more, so 3 is going to be part of the LCD. So that's the LCD. Okay, when I look at this, 7 and 21, 21 is the smallest both of those can go into, so that's part of the LCD. Then when I look at x, we have to the 5 and to the 3. 5 is more, so that's part of the LCD. And then I look at the x minus 2. We have 2 here and 1 here. 2 is more, so that's part of the LCD. Okay, let's look at the number. 18 and 36. 36 is the smallest number those can both go into, so that's part of the LCD. And then when I look at the 2x plus 1, I have 2 here and 3 here. 3 is more, so that's part of the LCD. And then I'll look at the 3x minus 5. I have Oh, I forgot my x. I have 1 here and 0 there. 1 is more. So let's put the x first. You have to put the monomial factors first. And then I'll put the 2x plus 1. And finally, I'll put the 3x minus 5. Now, for the 3x minus 5, you have 1 here and 0 here. 1 is more, so it'll be a 1 there. So all of that is the LCD for that. Okay, now these are not factors, so that's got to be the first step. I've got to factor this, and that's going to be x minus 4, x plus 2. And I'll factor this, and this is going to be x plus 2 squared. So when I look at the factors, we have x minus 4 and x plus 2. For the x minus 4, it happens once here and 0 times here. Once is more, so it'll happen once here. For the x plus 2, it happens once here and twice here. Twice is more, so it's going to happen twice in the denominator. And that's it. Okay, because this is a common denominator, I can just add the tops and keep the denominator. So I have x plus 1 plus 5 over 2x, which is x plus 6 over 2x. Again, we have a common denominator, so I'm just going to keep the denominator and add the numerators. So this is going to be 4x plus 4 over 2x minus 5. Now the top is factorable, but it doesn't help us. I mean, you could factor it. But because nothing is left to cancel with the bottom, I could just leave it like this. If I put this over this, that's okay too. But I'm going to leave it like the first way. Now, be careful because we have a common denominator, but this negative is going to distribute to every term here, not just the first term. So when I keep the denominator 4x minus 3, I have 2x plus 1, and then I distribute the negative, and I get negative x plus 3. This is where people will make the mistake. And then when I combine the numerators, 2x minus x is x, 1 plus 3 is 4 over 4x plus 3. So that's the answer. Okay, we have a common denominator, so I'm just going to add the numerators. And you don't have to worry about distributing a negative. It's only when you have a negative that I worry about that. So on the top, I have 2x plus 7 plus 4x plus 3 over 3x plus 5, which is 2 plus 4 is 6x plus 10 over 3x plus 5. But the top is factorable, and we have to factor it because it's going to help. We take out a 2, and we have 3x plus 5 over 3x plus 5. And now this entire thing cancels. So the final answer is just 2. First thing you want to do is determine the LCD. We have an x minus 1 and a 3, and they both happen once. So the LCD is is 3 times x minus 1. So I'm going to make two fractions. I have 1 over x minus 1 plus 1 over 3. Now, I need to make this a 3 times x minus 1, so I got to multiply the top by 3 as well. And in other words, I multiplied both the top and bottom by 3. And then I have to make this look like this, so I have to multiply by x minus 1. So I have to multiply by x minus 1 on the top as well. So now on the top, I've got 3 plus, when I distribute a 1, it just stays x minus 1 over, now I have a common denominator of x minus 1. And finally, I combine like terms, and this gives me an x plus 2 over 3 times x minus 1. Okay, first thing we want to do is determine the LCD. Because these are different, the product of these is the LCD. So the LCD is x plus 4 times x plus 5. So if we start with this original 5 over x plus 4 minus 3 over x plus 5. Now, we need to do what we need to do in order to make this look like this. So we need to multiply this by x plus 5. And if you do that, you have to do that in the numerator as well. And then now we have to make this look like this by multiplying each top and bottom by x plus 4. So since we multiplied that by x plus 4, we have to multiply this by x plus 4. So the numerator, we're going to distribute that 5, and we're going to get 5x plus 25. Here we're going to take the negative and the 3 and distribute it. Negative 3 times this is negative 3x, and negative 3 times 4 is negative 12. So that's what we have now. And on the bottom we have x plus 4 times x plus 5. On the top, we're going to combine like terms. 5x minus 3x is 2x, and 25 minus 12 is a positive 13. So that's the answer. Okay, before we can determine the LCD, we have to factor these. So I'm going to factor this, and this is going to factor as x minus 3 squared. This is the difference of two squares, and this will factor as x plus 3 times x minus 3. So the LCD, when I look at this, I have x minus 3, and it's to the 2 here and to the 1 here. 2 is more, so that's part of my LCD. And then when I look at the x plus 3, I have 1 here and 0 here. 1 is more, so that's part of my LCD. So this is the LCD. Now I'm going to start with the 5, and on the bottom right now, I have x minus 3 squared. Then I have plus, and I have 2, and on the bottom here, I have x plus 3 times x minus 3. Okay. Now, in order to make this denominator look like this, I have to multiply by x plus 3. So I have to do that on the top of this as well, so I don't change the fraction. In order to make this look like this, I need to multiply by 1 more x minus 3, so I have it squared. So I'll multiply by x minus 3, and I got to do that over here as well. Now I'm going to distribute this, and on the top of this, I'll get 5x plus 15, and I'll distribute the positive and the 2. Positive 2 times this is a positive 2x minus 6. I'm going to do this wiggly line because I'm just saying that it's the same thing as this. I don't want to write it again. So now I'm going to combine like terms. 5x plus 2x is 7x. 15 minus 6 is a positive 9 over, and I have x minus 3 squared times x plus 3. Okay, my only two denominators are x minus 5 and x plus 2, so the LCD has to be the product of those. So now let's write these fractions, and I'll give myself some room, but I'll write these fractions the way they are now. So far I have x plus 4 over x minus 5 plus, and I have x minus 8 over x, what am I doing? Over x minus 2. Now I put them in parentheses because I'm going to need to multiply this by something in order to make it look like this. So I got to multiply the bottom by x minus 2. So I multiply this by x minus 2. That means I have to do that to the numerator as well so that I don't change the fraction. And then to make this look like this, I have to multiply this by x minus 5. So I have to do that to the numerator as well. So the bottom is fine to leave it like this, but the top I'm going to have to FOIL so that I can combine these numerators. So foiling the numerator, the first is x squared, the outer is negative 2x, the inner is a positive 4x, and the last is a negative 8. Then on this, on this one over here, the first is x squared, a positive x squared. The outer is a negative 5x, the inner is a negative 8x, and the last is a positive 40. all over the denominator of x minus 5 times x minus 2. And if you want to write this as a squiggly line, you can do that just to save some time, and then write it back when you're done. So now in the numerator, I have 1x plus 1x squared is 2x squared. Let's see, this is positive 2x so far. 2 minus 5 is negative 3. Negative 3 minus 8 is a negative 11. And then we have negative 8 and positive 40. That's a negative or positive 32. And I'm trying to figure out if I can figure out a way to make an 11 in the center. Well, let's see, 2 times 32 is 64. I don't think there's any factors of 64 that add up to 11. 1 and 64, 2 and 32, 4 and 16, 6 doesn't go into it, 8 and 8, none of them work. So this is prime. So now I'll write the denominator. I tried to factor this to see if there was anything that I could do to factor so that I could cancel down here, and I can't. So I'm left with 2x squared minus 11x plus 32 over x minus 5 times x minus 2. Okay, this is a rectangular garden, so let's start right there. Draw a rectangle. Now it says the length is 5 feet more than 3 times the width. We don't know the width, so we'll choose x. 3 times the width is 3x, and 5 more than that is 3x plus 5. The area of this is 100 square feet. Now, in a rectangle, length times width is equal to area. So the equation is x times 3x plus 5 is equal to 100. I'll distribute this and get 3x squared plus 5x, and I'll move this over, so it's minus 100 is now equal to 0. This will factor as 3x and x. Let's see. Let's go 10 and 10, 20 and 5. Yeah, let's do 20 here and 5 here. If I do plus 20 and minus 5, what that does is I have 3x squared as my first. The outer is negative 15x. The inner is positive 20x. Negative 15 plus 20 is positive 5. And then negative 5 times positive 20 is that. So let's bring this up here. So this tells us that x is equal to negative 20 over 3 and positive 5. But negative 20 over 3, we can go as small as 0, but we can't go negative. It doesn't make any sense. So we have to throw this out. So now we know that x is 5. 3x plus 5 is the length. 3 times 5 is 15. 15 plus 5 is 20. So this is in feet. So the dimensions are 5 feet by 20 feet. Okay, one integer is 5 more than another. There's the sum of their squares. Let's start with the integers. So I'll say x is equal to the smaller integer. And one integer is 5 more than the other. So x plus 5 must be the larger integer. The sum of their squares. Well, the square of this is x squared. The sum is addition. The square of the next one is x plus 5 squared is, 3 less than 25 times the smaller. Well, this is the smaller. 25 times that is 25x. And 3 less than that would be like that. So let's do the left-hand side. X squared plus. This, if you don't remember how to square a binomial, just FOIL it. Something squared is something times itself. And then FOIL. The first is x squared. The outer is a positive 5x. The inner is another positive 5x, and the last is positive 25. So this is equal to that. So now, combining like terms, 1x squared plus 1x squared is 2x squared. 5x plus 5x is positive 10x. And we have plus 25 equals 25x minus 3. Now I'm going to bring this way and this way. So I have 2x squared. 10x minus 25x is a negative 15x. And 25 plus 3 is a positive 28. So we'll factor this. Well, I'm trying to get to 15, so let's see. Maybe 7 and 4 will do it. Yeah, that looks right. If I put a 4 here and a 7 here, what that gives me is this. I have this, our first is 2x squared. The outer is negative 8x. The inner is negative 7x. Negative 8 and negative 7 add up to negative 15. And the last is a negative 7 times a negative 4, which is a positive 28. So that works. So now I'll bring this up here. And this gives me x is equal to 7 over 2. And this tells me that x is equal to positive 4. But the question started out by talking about integers. 7 over 2 is not even an integer. So we have to throw it out because it's not an integer. So we found the first integer, the smaller integer. The second integer is 5 more. 4 plus 5 is 9. So the integers are 4 and 9.